For people that missed Mondays and Tuesdays lesson, here's Arduino. Take a moment, read it, and see if you can answer these two questions. Pause me now. Go ahead and try it. I'm just going to keep going forward. So it says the quadratic function y equals 64x minus 16x squared calculates the height y of a golf ball in feet after x seconds. We should now know that, gravity works. Where everything you throw up and comes back down, quadratic function. You'll study it more in 10th grade when you take physics. So I wanted you to find the x-intercepts of this quadratic function, and we spend a lot of time on it. It's easy to find the x-intercepts because they have some really important thing in common, that their y value is 0. So you set the equation equal to 0. And now we should find what x makes it true. We discover that you can use factoring to get your answer there. So how many terms? 2. Is there a GCF other than 1? This time there is. You can pull a factor of 16x from both of these. And if you pull a factor of 16x from 64x, you're left with 4. And if you take 16x from 16x squared, you're left with just an x. All right. Now, because we have the zero product property, kind of easy to find out what value of x makes this parenthesis 0 will be one of our x-intercepts, because 0 times anything is 0. So that would be, 4 comma 0. And then what value of x would make this 0? And people always struggle, but 16 times what would make it 0, and it's 0. So there we go. We've got our x-intercepts at 0, 0, and 4, 0. I'm going to write those down here. So what do the points tell you about the height and time of the golf ball? I'll sketch it out a little bit. We know that one of the x-intercepts is here at 0, 0, and the other one's over here at 4, 0. And we can picture that guy hit the golf ball, or girl. And that's what we've got. But what do the points tell you? This is what I've kind of left out for a little while, but it's really important. What does the height and time tell you about the golf ball? And to help us, let's think the x-at variables stand for seconds, so time. And the y-coordinate is height. So what do the x-intercepts tell you about time and height of the golf ball? Well, 0, 0 means at time 0, the height was 0. And this one, 4, 0, tells you that when the time is 4, the height is 0. So what does it tell you about the golf ball? And so they tell you how long the golf ball is in the air. Because at both those times, it's at a height of 0, so that means the ball went up and came back down. So it tells you that they went 4, and if we label the axis, we might be able to see time and height. Yeah, so if you know the x-intercepts, you actually know how long maybe something was thrown up in the air, or you could kind of figure it out. You also maybe know where the vertex is, right? Because it's here, you know what time it happened at. People in the class said you could find it because it's halfway between the x-intercepts. So we know the maximum height was reached at 2 seconds. So kind of cool, we can start finding the vertex if we know the x-intercepts. All right, today's lesson, it's a short one, nothing big. We're talking about solving quadratic equations. Day 2, I wanted to give you a little bit more time to practice. So let's get into it. You can pause me anytime if you want to stop. So we're going to solve the quadratic equation for x. And what we decided is that, and kind of figured out, is that solving quadratic equations for x, we can use what we did when it comes to basically very similar to finding the x-intercepts. We have a quadratic equation equal to 0. And now we can try to factor. You always want to make sure your quadratic equation equals 0, so we're allowed to use that zero product property. So we'll get going. We want to solve this. We're going to say how many terms? 2. GCF other than 1? No. Oh, wait, yes there is. You can pull a 4 and an x from both terms. Then you're left with x minus 5 equals 0. And now we can kind of figure out 4 times what squared minus 20 times what equals 100. I meant equals 0. And now that it's factored, it's kind of easy, right? Because 0 times anything is 0. So what would make this parentheses 0? Well, x could be 5. And what value of x would make this whole parentheses 0? Well, it's 0. Cool. So we solved it. We found both 5 and 0 work to make this true. And if you had questions, you could rewatch the video a little bit, but I just wanted to point out, notice how we didn't write them as x-intercepts. Because we're just finding values of x. So when we're asked to solve, we just need the x values. We don't need to write them as ordered pairs of like 4, 0 or 5, 0, 5, 0 or 0, 0. Oh, I'm making silly mistakes when I talk. Okay, next one. We want to solve for x. We want to figure out what squared plus 8 times a number plus 15 equals 0. I have no idea. None. But we can maybe try to solve it with factoring, right? So first step, is it equal to 0? Yes. Second step, let's try to factor this. 1, 2, 3 terms. There's no GCF other than 1. So we look at what's left, and it's in the form x squared plus bx plus c. So multiplies to 15. Sums to 8. Well, that would be 3 and 5. So, and because it's x squared, we can jump right to our 2 parentheses. Use a shortcut. X plus 3 times x plus 5. And now, kind of easy to see what the 2 values of x are. Right? Well, negative 3 would make this 0, and 0 times anything is 0. And we can make x is 5. Negative 5, excuse me, because negative 5 plus 5 is 0. And there we go. We solved the equation by factoring. Okay, 2 more here. So we got 13x plus 30 equals 3 times x squared. We want to find the value of x that makes this true. So it's not equal to 0. So we have to do something on both sides to get it equal to 0. Most students decide to take away 3x squared from both sides, and then you get it equal to 0. But I'm going to encourage you to try to keep or make x squared positive. Okay, it's actually a lot easier if we have a positive x squared. You can still do it, it just takes a couple extra steps. You could kind of mess up, because if you have a positive x squared, you get x and x, or maybe 3x and x. So try to keep it positive. So instead of taking away 3x squared from both sides, what I would encourage you, and it's just a couple more steps, is undoing all this stuff and making this side equal to 0. You don't have to, but I think it's easier, and so I wanted to show you that. Okay, so that was the point of this one. Just try to keep x squared positive. All right, we're not going to finish. We're not going to factor that. I just want to point out that. And then here's the last one for today. All right, we want to find what squared plus 5 times a number equals 10. And we're going to do that. Well, is it equal to 0? No. So let's make it equal to 0 by taking 10 away from both sides. And now we have a quadratic equation that's equal to 0. And we're going to try to factor it. How many terms? 1, 2, 3. Is there GCF other than 1? No. Look what's left. Can be factored form. Yeah, it's in this form x squared plus bx plus c. So when things that multiply to negative 10 and sum to 5. So let me list out the negative 10. negative 1 times positive 10, positive 1 times negative 10, 2 times negative 5, and negative 2 times 5. Okay, those are all the whole numbers that multiply to negative 10. Whole number pairs. All right, and then let's check it out. So one of them, what multiplies to negative 10 and sums to 5? Well, negative 1 plus 10 is 9. This is negative 9. This is negative 3, and this is positive 3. All right, so which pair adds to 5? Well, none of them, interesting enough. So this is something that we learned back in chapter 7. This quadratic is actually unfactorable. We cannot factor x squared plus 5x minus 10 equals 0. It's unfactorable. But that doesn't mean that there isn't something squared plus 5 times the number that will equal 10, or down here. We just can't find it by factoring. Okay? So this is to preview us for Wednesday's and Thursday's lesson. We have to learn you might remember me saying there's actually 4 methods to find the values of x. Factoring just happens to be one of them. We're going to start with the other 3 methods and finish it up this year learning about them. So, and to be honest, once you learn the 4th one, if you never really want to factor again, you don't. Say like, oh, I don't factor anymore. That's awesome. You know, you don't have to factor if you know the 4th one. Then, Mr. Moran, why did we learn how to factor, right? Well, factoring is a lot easier. I always start with factoring first, depending on the problem. But, you know, you can use the 4th method if you would like every time. I personally like to factor, so that's why. So we have to leave this question mark. We need another method. Okay? So, and we're going to start that on Wednesday and Thursday. Cool. So your classwork is here and homework, so make sure you submit it. It's these 6 problems. You can see the answers are already there. So you probably want to take a moment and if you want to get credit, you need to show your work for these. Okay? So make sure you show your work and submit the problem, the classwork, the work for these problems. Okay? Show your work and get credit. Okay, so that's the lesson from Monday and Tuesday.